Hello everyone, welcome to Incredible Study. Today in this video we are going to discuss third atomic model, that is Bohr's atomic model, and in previous video we have discussed two atomic model, that is Thomson's atomic model and Rutherford atomic model. Therefore, without getting delay, let's get started. In the previous video, we have discussed about the Rutherford atomic model, and in that atomic model, we have also discussed about drawbacks of Rutherford atomic model. So, the drawback of Rutherford atomic model provided background for the development of new atomic model. So, Niels Bohr, he was a Danish physicist, worked with Rutherford in formulating the structure of an atom, and he used Planck's theory, that is theory of Planck and Einstein, to explain the stability of atom, and he put forward his atomic model in 1913 AD. So here we are going to discuss Bohr's atomic model, and Niels Bohr gave some postulates regarding this atomic model. So we are going to explain the postulates of Niels Bohr, that is Bohr's atomic model. So here I am going to write the postulates of Bohr's atomic model. Here you can see these all are the postulates of Bohr's atomic model. Niels Bohr gave these all postulates regarding his atomic model, that is Bohr's atomic model. So here we are going to discuss these postulates, and this is very important for examination point of view and for knowledge point of view. So here first number, a positively charged mass of a small volume is located in the small region of an atom where the entire mass of an atom is concentrated, called nucleus. So he told that, suppose this is an atom. So he told that in the first point, it is a small mass. It is a small volume of mass located in the small region. And it has positive charge where entire mass of atom is located. It means all the masses of atom is located or concentrated in this nucleus, which is located in the center and in a small volume. And second number point, a negatively charged electron of fixed energy revolves around the nucleus in a circular path called orbit. What he told in the second point, he told that a negatively charged electron of fixed energy revolved around the nucleus in a circular path called orbit. So he told that negatively charged electron, this revolves around the nucleus in the fixed path called orbit. Third number point, all the orbits associated with the fixed energy are called energy levels. They are as follows: E1, E2, E3 and ... En. Third number point, what he told that all the orbits associated with the fixed energy, it means this single orbit associated with different energies. Here fixed energy, they are called energy levels. It means different energy levels of having fixed energy. All the orbits associated with the fixed energy are called energy levels. They are called energy levels. They are as follows. It means they are denoted by E1, E2, E3 ... En, where E1 is the first energy level, E2 is the second energy level, E1 is first energy level, and so on. Here, and their capacity or their energy are as following. It means their energy is in this order: E1 is less than, E2 is less than, E3 is less than ... En. En is the energy level having greatest energy. It means having more energy. Fourth number point, when the electron revolve in the fixed energy levels, the electrons neither lose nor gain energy. Gain and lose of energy is only possible when electron changes its energy level. In the fourth number point, he told that when the electron revolves in the fixed energy levels, the electron neither lose nor gain. It means when the electron revolves in fixed energy level, then electron neither loses nor gains energy. It has constant energy when it revolves in fixed energy level. So gain and lose of energy is only possible when electron changes its energy level. Suppose second energy level is this is. So when electron changes its energy level, then only electron gains or loses its energy. Fifth number point, lose and gain of energy occurs in the small pocket of light called quanta, in the form of a small pocket of light called quanta, So this is simply to understand lose and gain of energy. It means electron loses energy or gains energy in the form of a small pocket of light called quanta. That small pocket of light called quanta. Here 6 number, the electron revolves in its orbit only if its angular momentum is equal to nh beta 2 pi. It means nh upon 2 pi. If its angular momentum is equal to nh beta 2 pi, then only electron revolves in its orbit, otherwise it doesn't revolve. And here in 5th number, lose and gain of energy occurs in the form of a small pocket of light called quanta. So it means lose and gain of energy we can write here E1 minus E2, that is equal to h nu. We can write here del E is equal to h nu, where this is the frequency of radiation. And this is Planck's constant. And the value of this Planck's constant is 6.62 into 10 to the power minus 34 joule second. This is the value of Planck's constant. So here we have studied these postulates, the postulates of Bohr's atomic model, and this is important as I have told earlier. So now we move to next topic, that is hydrogen spectra, Bohr's theory of hydrogen spectra. This is also important. Now we discuss Bohr's theory of hydrogen spectra. When electric discharge is passed to the molecules of hydrogen gas, then the molecule of hydrogen gas dissociates into atoms, and the solitary electrons of atom gains energy and becomes excited, and they jump to the different higher energy levels. But when electric discharge is cut off, then they loses the energy in the form of a small pocket of light called quanta, and they fall from different energy levels to its own state. And when the radiation is passed through the prism, then the discontinuous spectral lines are formed. That is why this theory is called theory of hydrogen spectra. And now I am going to write this theory on board. Here you can see this is the explanation of Bohr's theory of hydrogen spectra. So here, when an electric discharge is passed through hydrogen gas at low temperature, the molecules dissociate into atoms. Molecules dissociates into atoms. The solitary electron of hydrogen gains energy and becomes excited. Then they jump to different higher energy level, and when electric discharge is cut, next part, when electric discharge is passed through the hydrogen gas at low temperature, then the molecules of the hydrogen gas dissociates into atom, and the solitary electron of atom gains energy and becomes excited, and they jump to different higher energy levels. And when electric discharge is cut off, they lose their energy in the form of small pocket of light called quanta. Here, small pocket of light called quanta. Small pocket of light called quanta, and fall from different higher energy levels to its own state or its own energy. So in the next part, what is when electric discharge is cut off? When electric discharge is cut off, then what happens? They lose their energy. They lose their energy, and they lose their energy in the form of a small pocket of light called quanta, and fall from different higher energy level to its own state. And when such radiation is passed, radiation is also released. And when such radiation is passed through prism, then what happens? Discontinuous spectrals are formed. Then the discontinuous spectrals are formed. That is why this theory is called theory of hydrogen spectra. So this is the explanation of Bohr's theory of hydrogen spectra. And on the basis of wavelength, spectral lines are separated into different series. So now we are going to deal that topic. Here you can see, on the basis of wavelength, these spectrums are categorized into 5 series. It means these spectrums means that spectrals. Okay. So on the basis of wavelength, these spectrums are categorized into how many series? 5 series. They are Lyman series, Balmer series, Paschen series, bracket series, and P-Fund series. I know these names are not familiar to you, but it will be familiar to you soon. First one, Lyman series, Balmer series, Paschen series, and bracket series, and P-Fund series. Trick to learn this series. That is, first write L and BP. Simple. This is very simple to learn. Okay. Here, first number, Lyman series. Those series of spectra formed due to the fall of electron from the higher energy level to the first energy level. They are called Lyman series, and they are generally found in UV radiation. It means UV region. They are found in UV region, present in UV region. Balmer series, for these are those series in which simply write the series of those spectra formed due to the fall of electron from higher energy level to the second energy level. It's called Balmer series, and this is present in visible region. Third number point, Paschen series. You can define now by taking the help of these two. The series of those spectra formed due to the fall of electron from higher energy level to the third energy level is called Paschen series, and these are those series which are formed due to the fall of electron from higher energy level to the fourth energy level. And these are the series of those spectra which are formed due to the fall of electron from higher energy level to the fifth energy level. And this Paschen series is present near infrared ray, and this is present in the middle of infrared ray, and this is present in far infrared ray. So here I am going to explain only 2, and you can write the definition of these all 3. Okay. So here now I am going to write the definition, explanation of these 2 series. Here you can see this is the definition of Lyman series, and this is the definition of Balmer series. It means the series of those spectra which are formed due to the fall of electron from the higher energy level to the first energy level is called Lyman series. They are present in UV region. Second, those series of spectra formed due to the fall of electron from higher energy level to second energy level is called Balmer series. They are present in visible region. And likewise, you can write the definition for Paschen series, bracket series, and P-Fund series. I have written its second point, that is like this: they are present in visible region. Like this, for Paschen series, they are present near infrared ray. And For bracket series, they are present in middle infrared ray, and for p-fund series, they are present in infrared ray. You can see the series over here in figure. What happens from higher energy? These all are higher energy levels. These all are high energy levels. And from these higher energy levels, the spectra fall to first energy level. You can see this is first energy level, second, third, fourth, and fifth. So from higher energy to the first, this is which series? This is Lyman series. Let's write L. And from higher energy level to the second energy level, this is which series? Here, this is Balmer series. Right? B for this. And from higher energy level to first energy level, this is Paschen series. And from higher energy level to the fourth energy level, this is series, that is bracket series. And this is last from higher energy to the fifth energy level is p-fund series. This is p-fund series. Now you can see these all are the explanation of series of which are based on wavelength. These are the series of a spectrum which are based on wavelength. You can see the explanation of these all, and you can write the definition for these three series. They are easy. Just change the here third, fourth, fifth like that, and you will get definition. Now we discuss the limitation of Bohr's atomic model. Here you can see these are the limitations of atomic model, that is Bohr's atomic model. First number, he only discussed about the single electron element, that is hydrogen. He did not discuss about multi-electron element, that is other elements except hydrogen. He only discussed about single electron element, that is hydrogen. Second number, hydrogen spectra is the collection of many fine lines. But he did not deal about that. Third number, splitting of hydrogen spectral in magnetic field called Siemens effect and in electrical field called Stark effect was not explained by Bohr. So these are the limitations of Bohr's atomic model. In this way, we have completed this video atomic structure completely. Therefore, this video ends here, and I will catch you up in the next one.